Hello and welcome to SDA Tech Forum. So this is a new video series. I'm starting software-defined access, but on my screen you can see port-based network authentication. So why so? Software-defined access is a very large solution, and it is encompass of multiple technology. I was thinking for some time, like, since this is a very large solution, like how to start, from where to start. I can obviously start from top down, like the thing at control plane, then data plane, and some of the management plane. Or I can break it down into multiple technology pillar and start giving you a individual technology introduction, know-how, and then we stitch them together to understand how things work together as a solution. So that's where I decided to start this, and port-based network authentication is at the very bottom of the solution, right, where actual users connects, right? So let's focus on port-based network authentication, or 802.1x, or we fondly call it .1x. Understand the know-how, and then I'll show you how this fit with SDA solution, or software defined access solution. So what is an agenda for us? The agenda is what is port-based network authentication, how it evolved. So it evolved from port security, Cisco port security, which is a precursor of this .1x. .1x, little bit more about .1x. When I call .1x, you can understand that 802.1x and .1x, I'm using them interchangeably just for easy conversation. Then we talk about different nomenclature on .1x, what is the default behavior, and EAP, the underlying protocol, right? So how the packets exchange. There is another layer of protocol called EAP, and I'll show you the EAP packet walk, or a little bit of deep dive, and then we'll see how .1x and EAP work together, some additional use cases, and then we're going into the live demo. All right, so let's see what is a port-based network authentication. So you don't worry about this complex picture as of now. We will come back and revisit it, but for now focus on 4 steps. So a client or a user device request a service. In this case, I am requesting access to the network, okay, not to any particular application or something. Step 2 is verify the client's claim of identity. So your client is asking requesting access. On network side, you want to verify the identity before you grant the access, which is called authentication, right? How they authenticate, that may be like multiple variety of protocol you can use, but on very simple level, the authentication happen when somebody requests the access. Grant or deny services as per policy. So once you are authenticated, you may be allowed services or deny services as per policy defined, which is called authorization. So once you are admitted, what you can do, right? And step 4 is some additional. This is optional, so you can send optional policy also from the server, authenticating server. So here, try to look at this 3 component of this .1x solution. Your user device, then your network authenticator, and this is the radius where the actual authentication happens. And we'll come back and revisit this picture, but let's look at some theory. So before .1x, port security existed, right, in Cisco devices. So what it can do, it can allow specific MAC addresses associated with the port. So you can say that you are expecting only this MAC addresses or these clients to connect to this port. That's how you ensure security. You can allow finite number of MAC. You can say 1 or 10, right? Any combination of 2, obviously. Authenticating a device based on MAC address. End device did not participate in process, right? Okay. What it could not do, authenticating a user So if it is a shared PC, for example, they are sharing MAC address, so you cannot actually differentiate between your user. Assign a dynamic policy. You cannot assign a dynamic policy, as I mentioned earlier, like step 4, optional. You can enforce policies also, but with a port security, you cannot assign a dynamic policy. And periodically re-authenticate. So once you authenticated, how you want to make sure that the user is connected for longer duration is still a legitimate user. So you cannot do periodic authentication, and all these pitfalls are addressed in .1x solution. So let's talk about 802.1x on high level. It is a standard from IEEE. It's a framework designed to address and provide port-based authentication. So it's a framework. It's not like a guided solution. That means the underlying how you authenticate, how you authorize, you can still choose, pick and choose multiple variety there, right? So it's a framework for port-based authentication. Primarily, 802.1x is an encapsulation defined for EAP over media, and in this case, LAN is the key protocol. So EAP is our key protocol. .1x is a layer 2 protocol for transporting authentication message. So EAP is used for authentication between supplicant and authenticator. Don't worry about supplicant and authenticator. I'll walk you through the nomenclature in next section. So .1x talk about device roles. So there are 3 device roles. Supplicant is a IEEE nomenclature. So but in general sense, we say client or user or PC, which is requesting access. So think about your end host. We call it supplicant or client. Authenticator, again, IEEE nomenclature, IEEE nomenclature, and in common languages, we call it network access device. So authenticator is who is accepting the access request. And then you have authentication server. So NAD or my switch does not authenticate. It actually refer to radius or TCACs for authentication. And radius and TCACs in turn, they can integrate with the Active Directory or a local database so that all the user credentials and everything network access device can extract from third party. And that's where the authentication server comes into picture. It also helps us to enforce dynamic policy, and I'll show you when we do it in demo. Okay, so these are like nomenclature: client, network access device, and authentication server. .1x make use of 3 protocols to work together. Obviously, on .1x, 802.1x protocol itself, because it's a framework. EAP carries authentication and authorization data. So this is our underlying protocol. And then you have radius, which work as authentication server, right? So let's understand the default behavior. What happened when you configure your network for .1x? So before .1x authorization, so if the port is not .1x authorized, MAC address of end station is unknown. So there is no MAC address learning happen. Before .1x authorization, spanning tree is not in forwarding state for the switch port. So you will not get spanning tree go into forwarding state because you have configured this port, this switch port for .1x, right? Before .1x authorization, no traffic can be passed by switch CPU with the exception of CDP, STP, BPDU, and EOPL, right? So you are trying to secure a port, right? But if you block all the traffic, then even the authentication packet will not make it, right? So that's why we block all the traffic except some of the critical one, which is really necessary for authentication to go through, like CDP, BPDU, EOPL. And this is EAP over LAN, okay? 8.1x state machine directly relate to the link port, and by default it is a single auth mode. So it one-to-one authorization, one MAC address, one authorization. Authenticated session bound to MAC address used to authorize the port. So authentication sessions, they are bound to the MAC address which are authenticated. After now, what happened after .1x authorization? MAC address of end station, only one MAC address of end station, only one allowed on the port. So only one MAC address is allowed which is authorized, right? The network operation ensures the validity of authentication process, and network cannot be compromised by non.1x client or non seen on the wire. So only which MAC is authorized, that traffic is allowed. Other non authorized traffic is not allowed. So that's the default behavior. I'll paste this so that you can do reading at your leisure, but that was really important to understand. Now let's talk about the underlying protocol, which is EAP, and as a full form, Extensible Authentication Protocol. So a flexible transport protocol used to carry arbitrary authentication information, not the authentication method itself. So it is used to carry authentication information. It's not an authentication method itself. Okay. Typically run directly over data link layer as PPP or 802 media. So it's a layer 2 protocol. Transport authentication information in form of EAP payload. And I'll show you when we look at the packet, right, how the transport authentication information is transported. A switch or access point become the conduit for relaying it received EAP packet at authentication server by radius. So you can see that here is my user, here is my switch, and this is my authentication server or radius, right? So there are three states. When the thing is not authenticated, you see from user to network device, it's a single port connection, but two channels are open. One is uncontrolled, one is controlled. So before authentication, it's only uncontrolled is open. Uncontrolled port provide path for EAP over LAN traffic and CDP. So this channel is through, and all the packets are dropped except CDP, EAP OL only, right? It make it to the radius and then authentication happen. Then you get the control channel open. And what happen when control port is open? When control port is open, the control port is open only when the device connected to port is authorized by .1x. So when the authentication or the authorization happen, then this control channel is open. For each .1x switch port, the switch create two virtual access at each port. Yes. So whenever you configure your switch port for 802.1x, two virtual access is created, uncontrolled to start with, only uncontrolled, but in after authorization you have both open. Okay. EAP packet type. Now let's see how EAP help you to carry authentication information, right? So there are different packet types. Specific EAP messages are used between supplicant and authenticator. That means between a user and a switch. EAP start, EAP identity request, EAP identity response. So you can see, right, it's a sequence. So EAP authentication started, then identity request happened. In response to identity request, response happen, and finally when you want to sign off, right, you say that okay, I'm done, I'm moving my laptop or something, then you can do a EAP log off, right? So the port goes back to unauthenticated state. EAP identity response and subsequent EAP message relayed from authenticator to authentication server. So you can see that authenticator, which is my switch, is used as a conduit. So it is getting all the EAP messages and passing it to authentication server, which is radius in turn here. 802.1x and radius used to carry EAP between devices. See, so between the devices you use EAP, and this is the network people understand, right? All 802.1x frames sent to and from authenticator, to and for authenticator. So client and network switch, all this frame 802.1x frame is sent by using a reserved destination MAC of this, because you know that there is no MAC address learning happen, and if you want to send a thing, then you have to have a special purpose MAC reserve, right? which is in case of CDP also we have the same, or BPDU. So like that it happened, so that the packet is not discarded. And let's look at the packet form structure. So this is my layer 2 frame. So I have destination MAC, source MAC, type, Ethernet, and then within data you can see I have protocol version, packet byte, and then the payload. So packet type is actually where I tell you like what kind of EAP packet it is. So EAP packet 0 description, both the supplicant and authenticator send this packet. It is used during authentication and contains MD5 or TLS information required to complete the authentication process. EAP start, EAPOL start, sent by supplicant or user device when starting the authentication process. EAP log off, when user want to sign off, so terminate that session, it's an EAP log off. And EAPOL key, it is like a authorization information, right? Authentication information key, and we'll see when we revisit the picture. Okay, .1x additional use cases. So there are 2 more mode. Let's look at them first, and then we'll come back to the additional use cases. So .1x multi-host. So you saw that in default behavior section only single mode is supported. But what if you have multiple devices, you are connecting to the same port, or you are using a hub, right? Then use the multi-host mode, and what it does, it uses .1x to authorize the first connected device only, and any amount of additional stations subsequently allowed on the wire. Yep. So one host is authenticated, and if there are other hosts connected to the same hub, they can use the port. Then multi-authentication. So this is not very optimal, right? Then comes to multi-authentication. Multiple devices may connected to a single switching port. Each device must be authenticated. So here you may have like a high-speed port where you are using a hub and multiple users are connected. Every user need to authenticate, which is very good, right? Guest VLAN is not supported, and we will touch base upon guest VLAN in the SDA guest section. Okay, what is the additional use cases? What if you still want to give limited network access to user who doesn't have 801.1x supplicant? So .1x supplicant, I'll talk about that in a demo, but you need a special piece of software on your end station to authenticate. But what if that end device doesn't have that application or that physical supplicant? So what you can do, you can provide them a limited access. That also you can do with .1x. What if you still want to give limited access to the user who failed to authenticate? Also the user who failed to authenticate, what you want to do for them? You can still provide them limited functionality. What if radius server go down? Then what will happen? Nobody can connect to the network, or what, right? So that also you can address using .1x additional commands. Once the user is authenticated, can the authenticator give dynamic network policy for that user? So can you provide dynamic network policy? Obviously yes. Can you authenticate a user who lacks .1x supplicant based on MAC address instead of username and password? So yes, that is also possible. So these are the knobs available with the command line, and which can help you to address your use case. All right, now so we know about .1x, how it works, and we talk about the EAP as a protocol and understand different packet types. Let's go back and revisit our entire process flow, right? So coming back to this picture, here we have our 3 component: switch, end host, switch, and radius server. So what happened? EAPOL start, right? End user sends EAPOL start. Port is currently in unauthorized state, but EAPOL is sent to a particular destination MAC, which my switch recognize. Once it receives that packet, EAPOL start packet on uncontrolled channel, it send back identity request that please tell me your identity. Then client send identity response. Once it receives the identity response, it actually switch actually relay to the Radius server, and you can see that auth exchange with AAA server and authentication successful or rejected coming back. Whatever is the decision of Radius server, that is being passed to the client itself, and we are guessing that so there are two things. If port is authorized, the control channel open between them, and Radius additionally Radius and policy instructions. And if it is unauthorized, then just say that port is unauthorized, no, and go back to no control channel open, right? So so far, imagine or assume your port is authorized, and you receive the policy, and host continue accessing the network, and now it want to disconnect, so it send eep ol log off, and my switch actually understand that, and it just make the port unauthorized, and that's how the end user sign off. Actual authentication conversation is between client and auth server using eep. The switch is an eep conduit, but aware of what's going on. So that is very, very important. It's not a dumb relay. It actually understand if it has to open based on the authentication happen. It actually understand what control channel I should open, uncontrolled, controlled. So switch is pretty intelligent here. That's why sometimes you really need image upgrade or something to support this functionality. And here you can see .1x exchange here, and here is the Radius exchange. So auth exchange with AAA is exchange in Radius packets. So eep, request, response, everything is encapsulated in Radius packet and send it to Radius. That's why the demarc here. So here is .1x between switch and Radius is purely Radius request, Radius response kind of process. All right, let's go back to our live demo. So I have a switch here where I have a Windows VM connected, show run. And before I actually do that, one thing, so commands, there are multiple commands based on like different use cases, but at a bare minimum, you need 3 lines of command. One is .1x system auth control is necessary at the global level to start the .1x configuration, and on port basis you need minimum of 2 commands: authentication port control auto and .1x PAE authenticator. But you may have additional use cases. You want to do multi-host, you want to do map kind of authentication, so you will see variety of .1x command, but at bare minimum you need 3 commands. Okay, so let's go back to the switch, and this is a switch, a fabric edge switch for SDA, right? Because this I'm showing you SDA and .1x as part of that technology. So let's see what I have configured here. You can see I have some .1x timer commands, but we are interested in this source template. So we are not actually calling it directly. We have configured .1x using a template, but in your non-SD environment you really don't need a template. But what is part of this template? Let me show you the 2 line of command which you need: .1x PAE authenticator and access session port control auto. These are like 2 things you will need, right? And that's how I called it under my interface. And obviously on global level I have PAE enable 1x. Yep, you can see .1x system auth control. So 3 things connected, and now I'll show you how to verify if user is authenticated. So the command is show authentication session, your interface where the end host is connected, and say details, right? Show authentication session interface details. This is my interface. This is the user Fiona, okay? And right now she's not getting any IP address, so I will show you how to start a re-authentication. and all. So right now .1x is authenticated. Okay, and this is our Radius server. For Radius server, how Radius server will have user database, the most famous way is to integrate with Active Directory and have LDAP based authentication. But in our case, I'm using a user database locally on my Radius server, and as a part of identities. Please take a look. So I have a couple of users defined here, and these are the users I'll use when my end host is authenticating. And how do you want to monitor the logs? So you can click on live logs on Radius and see the authentication coming. I would like to filter it with my device name, so that we just focus on our device, because our device is edge 2, network device is edge 2, where it is connected. So now let me go and bring our client machine. That's the Windows machine in the lab environment. Okay, let me show you. Okay, let me log in. So this is my NIC card, and we are going to see how to enable supplicant. So you can see that I have the authentication tab here. Okay, that means that's where I can specify my .1x authentication parameter and enable it. But in case you don't see it in your device, that what you have to do, you have to go to services, so you can simply type services.msc and look for wired autoconfig. This should be in running state. Wired autoconfig service should be in running state. You can right click and do a start stop. For me it is running, that's why I see that's authentication tab here. So once you enable wired service running, you will have the authentication service available. Click on enable .1x authentication. You can choose your E protocol. I'm using protected E. Then under setting, I don't want to verify server connectivity. I'm using MS-CHAP version 2 for username and password. Select this, configure, come here. So I'm selecting my authentication method and go back, and you come here, fall back to unauthorized network access. But now since you enabled .1x, you selected your authentication method, where to specify the username and password. That's where additional, pick what you want to do. I want to do a user authentication, replace credentials. So you have seen that earlier it was authenticating using Fiona. Let me use Fred, my username, since this is the user already defined in my Radius server. Put your password. Once you put your password, okay, you'll see attempting to authenticate, and this is the good time to go to my switch and try to run the command again. You can see I'm authenticated using user Fred. It has got an IP address also, and .1x authentication is success. Please make a note of SGT value 16, since this edge device is configured for SDA. That's why Radius is pushing security group tag, which you can consider as a dynamic policy, right? And we will touch base upon what is SGT and how it works in our Cisco TrustSec video. So the port is authenticated, very good. You want to look at the from radius perspective, let's look at from the radius perspective. You can see that I have got an identity request Fred with the MAC address, and we'll verify the MAC address, and this is my authorization and authentication policy. If you want to get more detail, click on this tab and you'll see that how it is authenticated, what policy, and all those things. Basically what you would like to see is a 5200 and which host. So this is my switch's IP address, and this is the IP address of my end host, how it got. Okay, now let's go back to the switch, go back to the end host real quick, just to make sure that you see IP config. Okay, you can see that my NIC card has got the IP address and it doesn't show you the hardware MAC. So use this command with all, and here you can see DCA4, that is my MAC address, physical adapter address, and I have got the IP address, and that's what your switch shows, right? DCA4. Okay, so you have seen this in all three perspectives: client, switch, and radius, right? How client started authentication, switch interpreted that, send it in this information to radius, radius acknowledge, port is authenticated, now you communication is open. So you have seen this in action in all three places. Okay. Okay, so I think let me give you a quick bite on next video, right? How we will build from here. So already given you a bite, SGT value. So you, other than authentication, you're getting a SGT value. How SGT is making a play in SDA environment, I'll show you in another video. And here, look at one more thing, that what is the VLAN it is getting assigned to, right? It is assigned to, so now look at 1024. What happened to this interface when we authenticated, right? Yep. Switchboard mode access, and okay, show So you can see that my IP address, I got it from, sorry, I scrolled too much. Okay. Yep. 91.14, 172.16.91.14 and Fried, right? And my IP address 91.1 is VLAN 1025. Let's look at the configuration of VLAN 1025. 1025. We are forwarding campus and VN. So this is for my SDA user, and this is the IP helper address. This is actually my DHCP IP. So switch end host connected to the .1x authenticated port. It send a DHCP request, and it has got IP address based on the policy, right? So I will show you how my end host was able to connect to DHCP and how it got assigned to this VLAN. Okay, but you can see that VLAN 1025 is 91.1, and I have another edge switch in my network. Let me quickly connect to that. So this is edge 1. Show run INT VLAN 1025, and you can see I have the same VLAN with the same IP address configured here, right? This is a little different from traditional networking, right? You cannot have the same IP address configured on multiple switches, but this is called Anycast gateway, and you have the layer 3 gateway available on each and every access switches, right? That is Anycast gateway. So in my next video, I'm going to show you how the DHCP works in SDA environment and what is Anycast gateway. So stay tuned for that. Thank you very much.